I just, sorry, man. That's literally never happened.
Yeah, that's okay.
Uh, let's, hey, hey, everybody. Welcome back to another episode of the AI Applied Consortium podcast. It looks like we had a little bit of a glitch connecting to one of our channels, but it's Memorial Day. There you go. Now we're live on both of them. So probably nobody's listening. So just for context, uh, this series has been kind of developed through the consortium as a means to kind of share our thought leadership. We go through every week or 2 weeks, or on occasion 3 weeks, a different participant. I think we have a lineup of over 100 people in our schedule, from our trustees to our advisors to other ecosystem partners. And we talk about a variety of different topics focused on artificial intelligence and focused on our core mission, which is breaking barriers of artificial intelligence in different industries. So today I have a friend and colleague with me, Mike, who is a trustee to the AI Applied Consortium and a friend that I've known for several years now. And I invited him on Memorial Day to speak with me. I think we're going to cut things a little short today and do just a 30-minute session since everyone's on break. And the goal of which is to, again, spark your interest in artificial intelligence, focus on his expertise in the manufacturing space, so AI in manufacturing, and kind of talk through different things that both the consortium has been doing and get opinions and expertise from Mike on the topic of AI in manufacturing. So, Mike, why don't you just start by introducing yourself, and then we can open up a few interesting topics.
You bet. So Mike Burgess, VP of Ops at Crenlo Engineered Cabs, joined them at the beginning of this year, where we make cabs for some of the big names out there in off-highway, John Deere, Cat, etc. Spent the bulk of my career really in automotive parts supply, in casting, a little bit of ductile iron casting, and the bulk in high pressure aluminum die casting, safety components, and things like that. Been various roles: plant management, engineer by trade, or by training, I should say. It's been a long time since I've served that role, but that's it in a nutshell.
Okay. Thank you for that, Mike. So, just for additional context, Mike has been involved in the consortium now for several years as an advisor, an expert in the manufacturing space, and also as one of the 15 trustees that we have in the consortium. And we have, again, for additional context, different types of advisory councils focused in part on vertical market specific efforts around artificial intelligence. And one of them is the Manufacturing Advisory Council. So I'm going to start us off maybe at the top, if you will, how we got started together, and that is the work that we did around artificial intelligence and quality inspection, and how that translated to our AI manufacturing incubator, which is, in effect, it's a sandbox environment for manufacturers to be able to use artificial intelligence, test it, and develop different things around it. And one of the areas that you have a lot of expertise in and also contributed to is the quality inspection component of that incubator. And so I wanted to ask you, since this is kind of the birth child of our collaboration, tell me a little bit about the importance of artificial intelligence for a process like quality inspection, maybe the historical challenges of what quality inspection provides in manufacturing is that artificial intelligence can help in with, and then we can maybe unpack that a little more.
Sure. So, I mean, in manufacturing, quality obviously is it's got to be in the top three, if not number one, as far as customer satisfaction. And being in automotive, certainly in aerospace, there's a lot at stake. Anybody who's in the space knows those expectations have ratcheted, continuously, right? The expectations of the customer when it comes to quality. 100 ppm, 200 ppm in automotive world is the normal expectation. So the problem becomes if you don't have a process that produces repeatedly a quality part. A lot of people, you're forced to rely on inspection, visual human inspection, right? Everybody knows in manufacturing the adage, 100% inspection is only 80% effective. There was many days where I would have paid for 80% accuracy in inspection. So in the business I was in formerly, casting, there's some common defects that just inherent to the process. Porosity is the word, right? So holes, insufficient, not a complete completely solid part. So visual inspection, especially on machine parts, is very common. And again, through the years, the expectations on what is an allowable defect have, become less and less. To give you an example, on a machine surface, there's plenty of specs that say 0% porosity. There's quite a few that say 0.5 millimeter hole max allowed. Well, the irony is lots of companies are using their eyes to look for these defects, when I think there's some studies that show that, people can't even discern less than 0.75 millimeters repeatedly. So it's a big issue. And then the data collection that comes along with that. I mean, obviously you're always trying to continuously improve and develop a process that yields a good part 100% of the time. So now you're also usually relying on a human to document the issue. And it's costly, right? Especially in the United States, labor is very expensive compared to our competition. And, that's been historically kind of an unfair advantage, I guess you could say, or not an equal footing with, cheaper third party or, countries in the world. So namely China, right? There's opportunity. They can really throw a lot of people at inspection. Not to be a cop out, right? I mean, they also produce good parts and probably an order of magnitude better than they did, say, 20 years ago. So yeah, inspection is a necessity. A lot of times we depend on humans. Humans aren't great at it. And it's very costly. So it's kind of a vicious cycle.
Let me ask you, so you touched upon an interesting point, which I think is a good place to start unpacking. So this idea of costly resources, and the reason that connected with me is, we, as you know, right, we do work with United States Center of Advanced Manufacturing, which is, I guess, some sort of subsidiary. I'm going to probably botch the official construct, but of the World Economic Forum. And part of the collaboration includes thought exchanges and kind of think tanks that they organize or that we organize. In fact, they're going to be at this week's AI Manufacturing Symposium in Kentucky, and I was at this World Economic Forum a few weeks ago, where in effect the conversation was on a few different things, but it was workforce development, and it was this aspect of bring back manufacturing to the United States. And that was because it's in DC. In fact, the keynote was a congressman that was head or one of the senior members of the Energy Commerce Subcommittee. And he went on a few different topics, which we can discuss. But one of the things was, bringing back manufacturing to the US. And the people in the audience and kind of collectively in our discussion, they want that because they're all US manufacturers, but they challenge that as a straightforward, linear kind of ask, right? And in part, it's, what do we need to do to be able to adjust effectively to maybe market dynamics that are now pointing us domestically to do things. And so I wanted to maybe connect that to my thought, which is okay, automation, right? In areas that maybe are burdened with excessive costs, and now through AI or AI plus other technologies are now open to the opportunity to um, either reduce the cost of performing that. Like, and I know you've always kind of leaned on, I want to augment the user, right, with the ability to inspect so that there's still a person there, but one, that person is doing the job better, and two, maybe it doesn't need to be the relying on the one person that has all the legacy knowledge and has 40 years of experience, but rather on the younger, less experienced person, but the person that is now augmented with artificial intelligence in some form and can still perform the inspections as well as the person that had 40 years of experience. So that was a really long-winded way of maybe just talking about uh, workforce development, talking about uh, how AI plays in that, how AI plays in automation, and um, how maybe it enables some of these barriers of bringing manufacturing back to the United States in the various forms uh, that we need to be able to do, and something that is not, like I said, like a simple process. So somewhere there is a question, which is
Yeah,
basically,
yeah.
Mike, can you share a little more about your thoughts, I guess, suppose, on that?
Yeah, I mean, and maybe circle back to talk something very specific when you, as you mentioned, where we first started working together and why it was interesting. Um, what was differentiated it, right? So, um, in that case, we were doing a very difficult visual inspection. What the new technology combined with AI allowed us to try and consider um, was basically one, what most intriguing, I think, was the cost. I mean, easily order of magnitude less than conventional automation solutions, right? So, I mean, vision systems have been around for 20 some years. That's if you want to automate inspection, that's generally what you do. Cameras, lasers, lasers can find presence of holes or threads. But generally, you're almost in any application, you're at the six-figure mark, $100,000. The cameras themselves are, $5,000. We basically working, you and I and your team. I mean, we basically put together a system that utilized an existing robot that was basically unloading a washer, set it on a very inexpensive turntable, look at it with a $100 camera, and then toss it over to an edge computer. And like you said, it was augmented in that we let the computer and the camera do the hard work, which was just identifying potential defects, right? Indications. So it was scanning a part 360 degrees with the criteria, the inspection in criteria embedded in the computer. But the genius of it, I think, was, hey, operator, I found these three indications. I believe they're good or bad. Do you agree? And it allowed the operator, one, now that person doesn't have to visually look at all the surfaces, which is really with the bulk of the problem, right? Being able to detect it repeatedly. And then you built in with the operator response, no, it's good, or that wasn't a pour, that was a piece, some kind of debris on the part. So one, you've reduced the difficulty 90%. You've increased the accuracy. You've reduced the cycle time of that person. There's plenty of inspection based on the volumes alone that you could have literally 12 people at the end of the line all doing the same thing, right? And you did all of that, again, on the order of magnitude less than conventional systems. And you have a system, when you talk about workforce development, in a conventional vision system, from a custom automation house, you have to have somebody who has the skill set to maintain that, because that's the other problem with vision systems. And they've gotten a lot better, no question. But they really are only as good as the person who's programming it. So 9 times out of 10, you get a system, you get it working, and suddenly there's a condition in the lighting of the room. Somebody knocked something, moved it slightly, and now you have to have a pretty skilled technician, and it kind of segue into workforce development and automation. I would say there's nobody. Somebody's going to prove me wrong, but there's no universities that I'm aware of that are giving people that kind of specific skill set. I mean, vast majority of the time, you're training someone, you're sending somebody to go get trained. A pretty expensive training, right? Whether it's robotics or PLC, Cognex cameras, Keyence cameras. In order for them just to maintain the system, you spend $100,000+ for. All of those things seemingly can be impacted for the better with, AI, augmented reality, edge computing, etc. So that's what excites me specifically when it comes to inspection in manufacturing.
So I'm looking at my phone because I grabbed a screenshot of something that I saw before, but this one had the World Economic Forum on there. And what's interesting is as I'm reading it, immediately I thought that this was actually part of that World Economic Forum manufacturing think tank in DC, and they generated it from that based on our input. And I referenced, so part of the discussion was like, what are the necessary skill sets of the future? And I'm going to connect this to something we talked about earlier today. But if you look at it, 2030 skill sets, there's a lot of soft core skill sets like technology literacy. That's not too soft. Creative thinking, problem solving. There's empathy and active listening, motivation. Well, those are kind of common. Resiliency, flexibility, agility. And then AI, big data is there also. I'm telling you, I'm pretty sure this was directly from our session. But what I'm getting to is, and you see this more and more with a lot of the core technology skill sets for like software development, for example. So I think, and I mentioned this in the past, like software development is being turned on its head right now, with the capabilities of the code generation technologies that exist with generative AI.
Yeah,
you can stand up applications exponentially faster, and you can rely, I think, a lot less on coders and a lot more on architects, problem solvers, that are able to read code, decipher, architect solutions, and generate most of the code through code generation tools. So the way that, this is how I wanted to connect this, is where can AI help in the automation? And you pointed, and you kind of laid out a really cool example of this, which I connected to both in the manufacturing space, but more generally. And that's the idea of like talking to your data, talking to your operational technology line in ways where what you're saying has critical thought and problem solving skill sets, but it abstracts you from hyper level of in getting in the weeds and understanding very specific technical details.
Yeah.
So, that's the same for code, but you gave the example, and I let you give it for operational technology, where maybe you can speak to an AI and using those core skill sets I outlined, be able to create and problem solve on the fly.
Yeah.
So if you remember the example, maybe you can kind of lead us into that.
Yeah, no, I mean, the thing that comes to mind, which would be revolutionary, I think, it feels as though we have the technology today to do it. I don't know that anybody has offered that service, but like you said, for one, really that's the number one skill set for anybody in manufacturing and you can make the argument, I think that's the only purpose we serve is we solve problems. So You know, great example of where I think the technology is here today. Again, I don't think anybody's offering is robotic programming, right? Um, the industry I was in for the bulk of my career, die casting, was probably one of the first industries to implement the first robot. So I've been in highly automated manufacturing for my whole career. Um, and so, you are beholden to how good your robot programmer is, right? That you can program a robot to do some material handling, and it will work, but it doesn't mean it was done right. Um, so I could see a time and place or now where you could actually, like you said, just, hey, here's a 3D scan of the environment. I'm going to label these locations. Here's a model, and this is what I want to do. Hey, I want the robot to go over here, pick this part up, and set it over here, right? In theory, we should be, with the technology we have today, that should be doable. And maybe Fanuc or somebody else is offering that, I don't know. But so to your point, if that were the case, and I think it is a good parallel with what you're saying. I've actually dabbled with using Grok to create Python programs, and I have no idea what I'm doing, but I made it worked. So in theory, now you don't need to have somebody who is an expert in Fanuc or an Alan Bradley, but is an expert in asking AI to do these things and solve the next problem.
Right. Yeah. And I'm just, as you're speaking, I'm trying to break out the discrete technologies that we've already been, collaborating on in our incubators or with our ecosystem partners. So the obvious one is, fine-tuned, custom developed code generation for a combination of, what is it, like Pi logic plus the compact logic gated, studio code. So you can essentially program the PLC and then program the interface to the PLC automatically. And then those programming guardrails would be driven by different types of AI vision technologies and maybe some other guardrails that would understand and analyze the physical space and the instruction sets. Like we do a lot of work with multimodal, even in that AI manufacturing sandbox, where you can look at physical environments, images, video footage, and extract using vision and multimodal, both written context. So if you've ever if you use Grok, that's your preference. You dump an image into Grok, it interprets it, right? You dump an image into Grok and you guardrail with prompts, it interprets it with additional context. You dump an image into Grok, you prompt it, and then you guardrailed it with source documents, which I was just doing actually for legacy knowledge here on my laptop. It gives further guardrail, so you can get tons of insights out of that. And then you use vision technologies, and vision, which is kind of to some extent the basis of what the multimodal is doing, can do other things like understand the quantifiable dimensions of that physical space. You put that all together, in effect, you throw it in a blender, and you get the ability to generate like on-demand code based on both the instruction that the operator provides and all the other context that guardrail it. So that's the state of the art. That's, I think, probably something that we would be looking to build out here in our AI incubator, and we'll probably unpack this, you and I, on the side, since it is an interesting topic, and we didn't rehearse any of this, so it's actually interesting to talk about. So I wanted to touch upon one other quick topic which has a connection to all of this. So, and I'll come back to this World Economic Forum discussion and kind of the motivation behind that and the premise of bringing manufacturing back to the United States. And that's, you can make the argument, I think very obviously, that tariffs are part of the effort to try to re-stimulate and realign American manufacturing to be less reliant on external sources. Part of what was discussed there was some interesting stuff about adversarial governments withholding PPE in 2019 from the US. And obviously, we didn't have too much knowledge of what was going on in 2019 around COVID. But then it turned out, COVID. So, I mean, hypothetically, it all makes sense. And it's a challenging environment. I wanted to get your input on how challenging it is and what sort of, maybe ways in which AI can help without plugging the obvious, which is, as you guys probably all know, if you follow the podcast and our channel, is that we have put out a AI accelerator called Terra 360, which Mike, you had a chance to validate, like at least
Yeah.
through a demo,
Yeah.
and it was actually in partnership now with National Association of Wholesalers, which is a huge community of wholesalers, and with the U.S. Center of Advanced Manufacturing, we're building out different variations of that accelerator. And the real idea here is like we want to be able to show the power of artificial intelligence and connect it in practical terms to the community within the consortium. But anyway, the question is, how are you experiencing tariffs, if anything, on your end, or maybe how do you see manufacturers experiencing tariffs, and how do you see AI potentially helping them mitigate risk around tariffs?
Yeah. So in my current business now, certainly tariffs have had a major impact. We import quite a bit from China. Components that really there is no longer any supplier in the States or suppliers that are interested in our business. So pretty good chunk of, we assemble cabs. So quite a few SKUs in a cab. I mean, hundreds of thousands of components. So tariffs have had a major impact. It's obviously anybody who's had to track this is, it's very dynamic. It's probably an understatement. So yeah, massive impact. And I can see with AI, having been part of the team monitoring this and then, at least on the periphery of communicating it to our customers. It has not been simple. It's a heavy lift. We have the traditional MRP systems, but it really is a heavy burden on the people to interface with that system and identify, what's what. So, one area, with AI, I mean, obviously the application that we've generated, that's basically you can just start asking the questions and getting the answers, right? So it's kind of huge. If you could take, that structure and then LLM for your company, right? Load your all your data into a local language model. I think that would be massive to get into the answers quicker. And also, what are the things you haven't thought of? AI just can do that much more thoroughly and faster, and maybe just expose some of the areas that you might be at risk, right? We spend a lot. It's one thing to look at our supply base and do the work and come up with the impact, but what about the stuff that doesn't go into cabs, right? Just the stuff that goes into your stockroom. There's still probably an opportunity for us to use something like what the consortium has put together and say, hey, here's the stuff in my crib from these suppliers. We don't know where that stuff comes from necessarily, but in theory, AI would, or at least have a good direction and say, hey, let's say Fastenal, right, big name in supply. Hey, here's my spend with Fastenal annually. What percentage of this stuff is going to be impacted by tariffs? We don't have any visibility to that, but I'm pretty sure we could ask that question to Grok or ChatGPT, and them would have an answer, right?
Yeah, yeah, yeah. So I think we're going to try to get this in front of manufacturers in a larger scale here in the next few months through some of our partnerships and through the Manufacturing Council. So more topics to take offline. So Mike, I wanted to maybe ask you a couple of less structured questions, since I always take time at the end to maybe ask some casual questions and try to get some people to share with me on topics. I think the last time on episode 4, I asked a group president and a CEO if they, in effect, if they believe in aliens. But it was a little bit more of a grounded in artificial intelligence question, so it had some
Yeah.
sense. Anyway, so I won't go that route because I don't shock you. We know each other too well, so I can't throw you off. But I do want to ask you two things. When was the first time you were wowed by AI, and also at any point, when was the time that it scared you or the most?
Yeah. I probably started.
And you can go all the way back to Terminator 2 if you want. It's up to you.
Yeah. So I probably started interacting with ChatGPT, I don't know, 2-3 years ago, maybe. And I would get into arguments, and see where it would go. So I don't know that it's. I would say the first time it really opened my eyes to its capability was two things. One, like I said, I always had this idea where I was going to, potentially want to do some work in scraping data for my own personal use. I'm a big car guy, so I spend too much time looking at Facebook Marketplace and whatnot. And one Sunday, I just, I thought, maybe I could get a developer overseas to build this app for myself. Probably still cost $5,000, right? And it's like, well, that's a little steep for on a whim. But I basically explained what I wanted to do to Grok, and on a Sunday morning, within 2 to 4 hours, I had a functioning app that was scraping data from eBay, comparing it to Facebook Marketplace with Python. Like I said, I learned Fortran 77, so that's the extent of my programming knowledge. So that was eye-opening. The second example that was pretty amazing, like I said, I'm a car guy. I'm in the process of rebuilding an old Buick Roadmaster station wagon, and rebuilt the engine to a stroker, and getting into tuning. And I basically, through the help of Grok, completely tuned my own car. Like you said, I would first he showed me where to go, what software I needed, how to install it, which version of Chrome, all these things. Where do I get the cable? Hey, I'm having problems with the cable. Try this. To, all right, I'm starting it. Give me a break-in procedure. Hey, here's the data from the first drive, right? Here's the air fuel data. Tell me what I should do. Hey, okay, you should change your map settings. I mean, that service is like a $1,000 service if I had a third party do it, right? So that was pretty impressive. I mean, at this point, I don't use Google for anything. I mean, I use Grok. It's just more effective, fast.
Yeah, answer-based search in the future, right? I mean, that's another episode. That's interesting. But you're a car savvy individual. I think it probably helped in like guardrailing the answers, right?
One question, and I also learned. Grok isn't infallible. There's many times he repeated the same error, and I said, "Hey, I think you said this backwards." Oh yeah, my apologies. Right. So it's not infallible. It is it definitely has its faults. So you can't just blindly assume the data is 100% accurate, or the response, right?
Yeah, and the way that you guardrail that, you a couple of ways. One, innovation velocity is moving these large language models uh, into like unprecedented capabilities month by month, so they become better and better. Two, all those best practices of how you guardrail, fine tuning the models, making them domain specific, using document references explicitly in the way in which it picks up information. Because if it's not picking up information from a document, it is prone to higher probability of making mistakes as it returns you information. So you have to like you can handhold it, but if you build an application, that handholding is done completely on the back end. So if you were to build an application for tuning vehicles, you'd have, like, as a user, you'd still have the same interaction as you just did. You'd notice significantly less errors, but on the back end, it would be using Grok or whatever other large language model and all these other context specific components to be able to aggregate the information it needs and give it back to you. So that's kind of the way that would look like.
On the
Anyway,
programming side, what was really cool is, again, I don't know anything about Python. Here's the code. Okay, let me try it. Hey, it didn't work. This is the error. Oh, okay, change this. I mean, it was almost, all I did was feed the data back to it that it, generated by its code, and it fixed all the errors. So
yeah,
pretty wild for me. Maybe it's not for somebody who's a coder, but
no, I mean it is wild, and that's called vibe coding, by the way. That's the term.
That's my
Yeah,
new thing. Yeah, I do a lot of vibe coding.
Yeah. But I mean, it is becoming both more prevalent, but also more powerful, right? So definitely something that I would encourage everyone that hasn't coded to try that. Not on mission critical things or on your car, unless you have both car knowledge. As a disclaimer.
It's not my daily driver.
Yeah. Anyway, so I told you this would go fast, so we're actually over a little bit. But I wanted to thank you for taking time on Memorial Day. I got you stuck here with me for 40 minutes here, a little longer beforehand.
I gotta go. I know you were steaks here shortly, so
you're making me hungry. Yeah. So I know you're supposed to be at the AI Manufacturing Symposium and you couldn't make it this week, but you'll be there. You'll be there in spirit, and
yes, indeed.
Both there and at the cocktail, which I will mention. I will consume your spirits on your behalf as well. And again, like that, for the audience listening, we have this upcoming AI Manufacturing Symposium. It's hosted by the University of Kentucky. Well, for those of you that are interested in attending, there's plenty of information available on our LinkedIn page that can help you register. So it's still not too late. It's no cost. So we encourage manufacturers to attend, especially local ones that can get there. Mike, you and I, hopefully on the next symposium, we have these, now 6 times a year. We'll see each other.
Yep.
Probably in Chicago. And as far as the audience goes, our next set of podcasts will happen after the Manufacturing Symposium, and we're going to shift gear towards the next set of activities that the consortium is performing. So you'll see, I think we started with JR from Penn State, the Chancellor of Penn State. Then we went through Martin from BP. We went through Mike and a colleague of Mike's from the public sector group. Then we had TC and Pierre from our wholesale distributor group, and Mike, you're the fifth set on now. And the intention actually originally was to lead into the manufacturing event. So part of what we'll cover here, we're going to unpack further in the symposium for different presentations, demonstrations, calls to action, sharing our AI policy posture, which we submitted to the Office of Science and Technology around manufacturing, workforce development, and it won't be videotaped. So if you can't attend, that's the last chance you have to see that. But we do welcome, regardless, for everybody to reach out to us and engage us in our communities and our advisors and our trustees.
Yeah.
So thank you again, Mike. Appreciate your time, and thank you everyone for listening.
Thank you.